Hello, my lovely students. So now we're going to finish out our look at chapter 2. So this section is titled Right Triangle Trigonometry. I've already been talking about this some in class. I really latched onto this concept and held onto it firmly. So this is how I think about sine and cosine and tangent first. So one of the ways people learn it is TOA, which works, but the way I learned it was, the way I actually learned it from my dad was some old horse caught another horse taking oats away. Then I read about this one and it's way funnier. So some old hippie caught another hippie tripping on acid. So the first letter of each of those words is corresponding to all the letters I wrote over here. So sine is opposite over hypotenuse. So if this is our little angle down here that I marked with the little green arrow, the opposite side, if I draw an arrow, it goes to the side that's not touching the two lines that make the angle. And we're going to have a lot of interactions between the angle and that opposite side or the adjacent side. All right. So in the unit circle, since the hypotenuse is 1, that means our sine opposite over hypotenuse is just the opposite because the hypotenuse is 1. And then the cosine is adjacent over hypotenuse is just adjacent because hypotenuse is 1. So this is why in the unit circle, sine is y and cosine is x. Only when the hypotenuse is 1. For any other triangle, it is the ratio of sides. All right. And then we also have here 2.3 defines the other trig functions. So I just put a copy here just so it's, easy to see. All right. So we got a few practice and then we have some word problems. So here I have a triangle. My angle is labeled T. And I'm asked to evaluate sine, cosine, tangent, secant, cosecant, and cotangent of T. So if you look at this T though, the hypotenuse is not 1, it's 65. So we need to do this as the ratios. So our sine is the opposite side from the angle over the hypotenuse. So opposite from the angle is 33. And then the hypotenuse is always opposite the right angle. So that is 65. So that is our sine. Our cosine of t, that is the adjacent side over the hypotenuse. So same hypotenuse, 65. But our adjacent side is the side that's next to t that makes up one of the two rays of t, but not the hypotenuse ray. So in my head, I would always there's opposite, there's hypotenuse, so that's adjacent. Like my brain just kind of process of elimination to it. All right, so we have sine and cosine. Now from sine and cosine, we can get the other 4. All right, so our tangent of t then is going to be the sine 33 over 65 over 56 over 65, which notice the over 65s is the same on the top and bottom, so those will cancel. So our tangent is just 33 over 56, which if we look back at our triangle is opposite over adjacent. tripping on acid. Follows the pattern. All right, now the only other thing we need to do is our reciprocals. So the reciprocal of sine is not secant, but cosecant. So cosecant of t will be the reciprocal. Instead of 33 over 65, we have 65 over 33. Cosine goes with secant. This is 65 over 56. And then, of course, cotangent goes with tangent, 56 over 33. So as long as you remember those reciprocals, which one goes with which, then you don't have to remember, oh, it's 1 over x or 1 over y. Ugh. Those reciprocals are going to be far more useful to you than the xy definitions. And the xy definitions only apply in the unit circle when the hypotenuse is 1. The rest of the time, it's what we just did here. All right, then here, this is rather silly, but it's talking about complementary angles. So in a right triangle, I write my alpha, and then I label the other angle beta. So I know all three angles in a triangle add up to 180 degrees because it's a flat triangle. And I know one of the angles is 90. So alpha and beta here add up to 90 degrees. Mm, 90 degrees. There, now it looks like 90. All right. So if I get the sine of alpha, it's this opposite over hypotenuse. But for beta, this is the adjacent side over the hypotenuse. So the sine of alpha equals the cosine of beta. And likewise, the adjacent side to A, which goes with our cosine, is going to be the same as the side opposite B. All right, so like we can see that relation. And then if we plug in this relation, which beta equals 90 degrees minus alpha, or 90 degrees is pi over 2. So the cosine of beta is going to equal the sine of alpha, the other guy. So there's this like weird back and forth relationship. So we have t versus pi over 2 minus t. So if t is our alpha, pi over 2 minus t is the beta. It's just the other angle in the right triangle. So they took the sine and cosine relation and then expanded that into the rest, except for the last one in the table where they forgot to write secant. So many typos. We really do not make use of this that often. It's just more of a like a, huh. All right, so here, if the sine of t is 5 over 12, and then we can even fill it in. Sine is opposite over hypotenuse. The cosine of pi over 2 minus t. All right, if this is t, this is the complement of t. So this is pi over 2 minus t. The cosine of pi over 2 minus t is 5 over 12. But just knowing the sine of t is 5 over 12, I could Pythagorean theorem to get what the third side is. I could even, we'll learn later about inverse functions and figure out what the angle measures are. All right, over here, cosecant of pi over 6 is 2. So the secant of pi over 3, now note here, pi over 3 is pi over 2 minus pi over 6. So that's our alpha beta situation. Cosecant and secant, that's 1 over sine and 1 over cosine. So this is really the same relationship that we just used in example 4. They just wrote it with the reciprocals. As long as they're real numbers, it works. So if the cosecant of pi over 6 is 2, the secant of pi over 3 is 2. I think you might have like 1 or 2 of those on your homework, but they're kind of silly. All right, down here though, now we start getting into some word problems. So this setup here, we're told one of the angles, we're told one of the sides, and we're told it's a right triangle. And they ask us to find the unknown sides and angle of the triangle. So the first step here is being able to draw the picture. All right, so it is a right triangle, a hypotenuse of 20, and one of the angles is pi over 3. Or 60 degrees. So if we have 90 and 60 already, here, we'll just go ahead and we'll label this alpha. So 90 plus 60 plus alpha must be 180. So that's 150. 150 minus 180, alpha is 30 degrees. And then 30 degrees is not pi over 3, it's pi over 6. Now, generally in PreCal problems, if you are provided an angle in radians, then you should answer in radians. If they provide the angle in degrees, then answer in degrees. It's okay to do your work in either measure. Just make sure that you answer the question with the same units that you were given. Like here, we just told 20. We don't know how many units. Okay, so it's just 20. We can write units after it if we want. All right, so to get the other two sides, though, this is where we're going to use our trig function. So the sine of pi over 3 is going to be, I need to label my sides here now too. So if I labeled that alpha, I'm going to call this one A, this one B, and then this one is C. We know what C is. But it's alpha, the side across from opposite alpha is A, then this angle is going to be beta, the side opposite beta is B, and then the right angle, the side opposite that is C. Later on, this won't be a right angle, but we're still going to do this whole opposite thing, and this will be called gamma. But I'm just going to put that on hold just in case the book decides to pick a different letter. So the sine of pi over 3 is opposite our B side over C, our hypotenuse, 20. So the sine of pi over 3 is something that I can actually calculate on the unit circle, but I can also put it in on the calculator. So if I take my equation here, because most of the time when you get these kind of problems, it's not going to be an angle on the unit circle. It's going to be something ugly and you're going to have to use the calculator. So we have sine of the angle equals b over 20. So I'm going to multiply both sides by 20. So b is 20 times the sine of pi over 3. And when you go to crunch that on the calculator, make sure your calculator is in radians mode. Because if it's in degrees, pi over 3 degrees is a different animal from pi over 3 radians. So sine of 60, that's short, long, sine is y. So this is square root of 3 over 2. So we get 10 square roots of 3. Now, if we do the cosine of our pi over 3, we actually know what that one is. We had the square root of 3 over 2 already, so the cosine's going to be 1/2. But let me go ahead and write that over here. That's going to be a over 20. So we get 20 times the cosine of pi over 3, which is 20 times 1/2. So we get 10. All right, so we know our third angle is that pi over 6. One of our other sides is 10 square roots of 3, and the other side is 10. So when answering this kind of question where they say find the unknowns, draw a picture and label the picture. So that way when you write capital A equals 10, I can go look at your picture and see, okay, capital A was the length of the side. So they're saying the length of the side is 10. Although, like on a test, it'll probably be like 20 feet or 20 centimeters. So you'll have to put a unit with it, which also helps it make it clear what it is. All right. So there is the chance that you will have questions that ask or that talk about angle of elevation versus angle of depression. So an angle of elevation is something on the ground looking up at the top of a thing. Angle of depression is something up high looking down below the horizon line to something beneath them. Now, if the ground and then our horizontal line up there, which we think of as like the 0 sight line that you measure you're looking down from, the angle of elevation and the angle of depression are equal as long as the top and the bottom lines are parallel. So I'm just putting this here as like a reminder of those are words, these are what they mean in a picture. Now we get word problems. All right. So we have a question. How long of a ladder is needed to reach a windowsill 50 feet above the ground if the ladder rests against the building, making an angle of 5 pi over 12 with the ground? Round to the nearest foot. Alrighty. So again, step number 1 is draw a picture. All right, so here's our building. There's our window. There's our ground. All right. There's our ladder. So you should be able to see here that there is a right triangle in there. All right, so they're telling us that the windowsill is 50 feet above the ground. So the ground, 50 feet above it. This side of the triangle is 50 feet. Then we're told that the ladder is making an angle of 5 pi over 12 with the ground. So I look at the ground and my angle measure there. So this angle is 5 pi over 12. And then we go back, how long of a ladder is needed? The length of the ladder is the hypotenuse. So we can call this C. Sometimes I'll write like C equals question mark, meaning this is what I'm trying to find. So I have an angle, I have a side, and I have another side that I need to know. So I need something that relates these three quantities. So angle, and then I look, 50 is opposite the angle, and C is the hypotenuse. So what relates opposite and hypotenuse? Hopefully your brain is like, OH, some old hippie, sum is sine. So the sine of 5 pi over 12 must equal 50 over C. All right, so that 5 pi over 12 is some ugly angle measure. Sine of 5 pi over 12 is something that I can type on the calculator and get a result for. So this is number equals number over C. So I just need to solve this equation for C, and then I can punch in whatever weirdness I get into the calculator to do the calculation. So right now my C being in the denominator, no, I don't like that. So we're going to multiply both sides by C. On the right, it cancels out. On the left, we now have C times sine of our ugly angle is equal to just the number 50. And we'll remember later that's feet. Give me a sec. Give myself a little more room. All right, and then that sine of 5 pi over 12 is some number, so I can divide both sides by said number. Now, technically, 1 over sine is the same as cosecant, but you're not going to find cosecant on your calculator. So even though, yes, we could technically write it that way, we want a decimal because this also gave us rounding directions. So that means decimal answer. So now we get to see if OneNote will do trig functions. And it won't because it can't do pi. So now we get to see if I can make my phone do it. Okay. So 50 divided by the sine of, put an extra 5 pi over 12. Close, close. I got 2,180. That is not right. That is a ridiculous answer. All right. Sine of 5 pi over 12. Okay. I was in the wrong mode. So I got a ridiculously huge, like 2,000 something, and I'm like, there's no way this is a 2,000-foot ladder. So that's your common sense gut check. So 50 divided by the sine of 5 pi over 12. Okay. A little weird, but this is saying it is 51.76 feet. I guess so. So I was trying to figure out like how big is 5 pi over 12? Well, 6 pi over 12 is pi over 2. So 5 pi over 12 is really close to 90 degrees. So like this ladder is not that far away from the building. It's like, here's our building. And ladder is not like this. Ladder is like this. Very, very close. So the angle that the ladder makes with the ground would be almost 90 degrees, be very close. So this answer is reasonable. It's longer than the 50, so it passes like that first gut check. It's not a stupidly huge number, like 2,000 something. And then it did say round to the nearest foot. So this will actually be, we need a 52-foot ladder. All right, not bad, not bad. All right. 2 more. All right. So to find the height of a tree, a person walks to a point 30 feet from the base of the tree. She measures an angle of 57 degrees between a line of sight to the top of the tree and the ground. Find the height of the tree. All right, so there was a picture in the book. I didn't grab the picture in the book. All right, so she is. So there is tree. Then 30 feet away from the tree, and in math land, that means the center of the tree, kind of. She measures an angle of 57 degrees. Between the line of sight to the top of the tree and parallel to the ground. So, what is the height of the tree? So this is we can just call it X. So now I need a trig function. I have my angle, side opposite the angle, the side adjacent to the angle. So I need a trig function that uses opposite and adjacent. Adjacent and opposite. On acid, oats away. Tangent. So in our triangle, the tangent of 57 degrees is opposite our unknown x over 30. Well, and then I can just solve this by multiplying both sides by 30. All right. Let's turn this on the side, put it back in degrees. 30 times the tangent of 57. We get 46.1959, blah, blah, blah. They did not provide us with rounding directions. They gave us 30 feet, so I would either go with my just gut instinct of 2 places, which would be 46.2, or I would just round it to the nearest foot, making it 46. If there are no rounding directions, either of those is fair game. But we used our knowledge of trig functions, our calculator storing that data for us. It looks up the trig value. We don't have to look it up in a book. And our algebra skills to solve for the height of this tree. So it's a pretty tall tree. 46 feet, that's over 4 stories tall. Story is about 10 foot. And then we have this weird little figure. We're told to find x. Here's the smartass answer. Now, we all know that's not what I meant. I did not write the problem, though. That's clearly a screenshot. So we are solving for x. So we have very peculiar triangles nested inside each other. They both have the same height here, if you will. So that 115 is opposite the 56. It is also opposite the 35. And then the x I'm looking for is part of the adjacent side. So if that's x, I'm going to call this other one here y. And that makes that entire side there x plus y. So now I'm going to use some trig functions. So with my 56 in here, that's opposite and adjacent, so it's another tangent. So the tangent of 56 degrees is 115 over y. So I'm going to multiply by y on both sides. And then my tangent 56 is there, so I'm going to divide by it. So our y here is 115 over the tangent of 56. And this is something we could crunch on the calculator right now, write down the answer for. Now let me use my highlighter. So just focus on the big triangle now and the 35 degrees. So it's still 115 is the opposite, but this whole side is x plus y. So that's what we're going to use as the adjacent side, but we know what y is, so it's just going to be some interesting number crunching. Alrighty, so the tangent, you know what? The tangent of 35 degrees in our figure is 115 over x plus y. All right. So now we're going to multiply both sides by x plus y. Why you do this, pen? And then I'm also going to, that tangent is just a number. So I'm also going to divide this thing by the tangent of 35. So we end up with x plus y equals 115 over the tangent of 35. I can subtract y to the other side. So x is 115 over the tangent of 35 minus y, which is 115 over the tangent of 56. Now, don't try to get cute and try to combine these in any way, shape, or form. They don't. Just, we're going to type in this. Now, you do have to watch out for parentheses here. So most calculators, when you type a trig function, it will automatically open a parenthesis. So you're going to need to close that parenthesis. Now me, I don't trust my calculators very well, so I also put a set of parentheses around the trig function to say only divide by this thing. Then I have minus, and it's just a number on top, so I'm a little daring. I don't put parentheses around my numbers if it's just a number. But you could, it's not wrong. And then down here, it's going to be the same thing. So if you don't close that parenthesis that's around the angle, you're going to have the minus 115 over the tangent inside the first one, and we don't want that. We want this to be two distinct things, so be very careful about how you type it in. All right, we are still in degrees. So 115 divided by, open parentheses, tangent, which opens a parenthesis, 35, close, minus 115 divided by, open parentheses, tangent, and it opened a parenthesis, 56, close, equals. So we got 86.6685. That's what X measures. I have no earthly idea what Y measures or what X plus Y is, because they wanted X, I solved for X. This is mathematician being very, I did what you asked. I did not do more. Practicality, if you had to deal with this figure, it wouldn't hurt to have what Y is, have what X plus Y is, hell, have what the hypotenuse is. You might need those. You might not, though. All right, so I'm gonna try and share the screen, like quite literally show you my phone, and I can't tell if it's not reversed good. All right, so see I had the 115 divided by tangent 35 minus 115 divided by tangent of 56. So the calculator will do order of operations, but if you're not sure, you can put parentheses around each individual fraction. And then you can see there the decimal underneath. And I wrote down the first few bits of it. It doesn't give us rounding directions, so I would still leave the extra 2, so 86.67. And then if, on a test question, there would be some sort of units and we would want to write the units. All right, so that is it for the end of chapter 2. This is like the first real world application where you could actually potentially use this. And then what we're going to look at next is the graphs of sine and cosine. The graphs are not on exam 1. So just kind of try to separate the knowledge a tiny bit.